Hi, I'm here today at the Petawawa Research Forest, which is Canada's oldest operating research forest centre. We're here today to celebrate their 100th anniversary, so 100 years of studying the forest in this same locality. The research forest has been looking at different parameters and looking at silviculture and the establishment of the forest over 100 years using different technologies. We'll be talking to 3 collaborators today to look at how those different technologies have evolved over time and how the information, the knowledge, and the data that is collected here in the research forest, how it can be applied to solve today's problems and also to help sustainable management of the forests. We're standing here on the permanent sample plot number 1. I asked as we were driving out here, does number 1 really mean it was the first 100 years ago? So could you tell me a bit more about the history of Petawawa Research Forest, this permanent sample plot?
You know, it's so neat to have long-lived plots, as Donna mentioned. So if you can imagine in 1918, a stand of white pine after a fire that was about this size in diameter, the stems. And over this time in the 100 years, this has actually been harvested 7 times. And so you're seeing the benefit of removing some of the smaller trees, the poorer trees, and leaving the bigger trees to form the next canopy. Our diameters are larger, and we're trying to promote white pine regeneration to come forward. So we have a track record of individual trees measured over that 100 years, kind of measure between 5 and 10 years all the way along. So we can sort of see how trees grow, their growth rates, and how they die and how the stand composition changes over time. And we use that for modeling.
I know you weren't there 100 years ago, but
Thank
you may have a bit of insight to provide us on, what were we sampling 100 years ago? What were the techniques? How would we measure things, and for what purpose?
Some things haven't changed a lot in terms of what we're doing today. We would measure trees of diameters and heights, and so we would go up to each tree and we put a diameter tape or calipers and we measure the diameter, and that was our primary way of measuring the tree attributes.
Right, and so I guess over the years, the Petawawa Research Forest evolved from a couple of sample plots to more and more. Do you have any information on that evolution? So, and the different sample plots and how they evolved and for what purpose?
Sort of white pine regeneration, fire history, developing forest fire index system for forest fire prediction. For sure, regeneration, in terms of we looked at artificial regeneration, what's the appropriate planting density for species like red pine and spruce and jack pine, genetics work, all those stuff were established. So there's a whole range, and we were hearing some of the numbers like the 500 permanent sample plots that are out there. So we have many years of individual tree measurements that we can use in terms of modeling now, but also look at remeasuring now as climate change issues are being dealt with, to see what impacts we're seeing in those growth rates as we go forward.
Lee's talked about the partnerships here, which are really important. Murray, as he was introducing himself, he was saying that he actually originally worked with the provincial government, but is working with NRCan right now. So great collaboration between provincial and federal government. So we'll pass over to move on to Scott. So Scott, another different type of partner that we work with here in Petawawa, the users of the data and the information that we collect here. So maybe a few words on the importance of the Petawawa Research Forest.
I do forest management planning, and some of the really critical things that I need to be able to do is describe my forest as it is today. So a good inventory is critically important. Being able to say how has that forest changed over time in the past, and detect changes through time. So again, those inventory pieces of how is the forest described through different periods of time and through disturbances, whether that be through fire, harvesting, and renewal. But then the most challenging thing of all is then being able to predict the future of how is that forest going to develop 100 years from now. And we actually plan over a 150-year time frame. And so, again, by building models that we're projecting forward based on how things change through time in the past is extremely important.
So Bastien, I guess what I'd like you to talk a bit more about is what you're actually working on, and we were talking about using the latest techniques to be able to learn more and more about the forests and the trees, so that we can feed that into sustainable management practices. So how about you talk a bit more about your work?
Yeah, I'm kind of in a big project called the AWARE project, and it's a project across the whole Canada. We get a partnership with government, with a lot of wood industries, and also with a lot of university, and that's really interesting to be able to get access to all of this data here in Petawawa. And so what we're trying to do, I'm not the only one, we're a team of like 15 students involved in this project, is to get the help of the remote sensing technology to enhance forest inventory. So I'm looking at LiDAR technology.
So LiDAR, as a geologist, I've worked with LiDAR data. It's actually airborne, an airborne sensor that sends light down and receives it back up, and it gives you the height of different objects. So there's airborne LiDAR, and I think this is also a similar type of instrument, a LiDAR.
Yeah, so I can show you. This is a version of the This is a version of the laser called Kata Contour. It's a kind of it's a brand for this this laser scanning. So here it's pretty simple over there. You just need to put it down and just create a new project over there. And so when this project is done, what you just have to do is to walk into the forest. So I can just take a picture to show this will be the beginning of our scan. Yep. And then just put it down. Yep. And so what you see here is the LiDAR, it's moving in. The idea is that the sensor is going to move and get a 360 acquisition and then 190 degrees acquisition like this. So right now you are in the 3D point cloud. It's beginning to just throw a continuous laser signal, a light signal, and so as this rotating mirror is moving, you get million pulsation coming in here in these scenes.
So basically, we'll be creating like a video game of the forest.
Yeah, you can say that, not really a video game, but a 3D acquisition, yeah, for us, exactly. So you're gonna see everything here, the chairs, the trees, and the people, maybe.